going back to this idea of similar figures, we're talking now about similar solids or similar three-dimensional shapes. So for two-dimensional figures to be similar, we know their side lengths must be proportional. That's what makes them similar, is that they are proportional. The same thing is true about prisms, that the ratio of corresponding parts of similar prisms are equal. And the ratio of surface areas of two similar solids is equal to the square of the ratio between their corresponding edge lengths. So giving you what that means, like in a proportion, because that's the way you're going to see this, is that if I'm talking about surface area, the surface area of one shape divided by the surface area of the other shape is equal to the side squared divided by the side squared. As you'll recall earlier in 4.7, we talked about how we had to multiply, if for surface area, we had to multiply by the scale factor twice. We had to square the scale factor. And that's what we're having to do here, is we have to square our sides when we're talking about surface area. The same thing is true in prisms, that the ratio of corresponding parts of similar pyramids are equal. So this is true for both prisms and pyramids. Well, what about a sphere? Remember, a sphere is a circle. So all spheres, no matter what shape or no matter what size, are going to be similar, because the definition of similar is that they have the same shape, but they have different sizes. Well, all spheres are exactly the same. You don't have any with dents in them. If they had dents, they would not be a sphere. So why is that? Because all spheres are the same shape. Alright, so our question below says, if the pyramids are similar, what is the value of x in the larger pyramid? Well, looking at what they've given us, they've just given us side lengths. So this is a normal proportion. We don't have to square anything. We only square stuff if it's talking about area. So we could put 5 over 2. And if I did that, I would have to do 10 over x. Okay, because whatever goes on top, these two have to have something in common. So both 5 and 10 are our slant height. And I think it's very important to label your proportions, because then you make sure that you get them accurately drawn. And then both of our bottoms, 2 and x, well, they're part of the base, so that's what they have in common. So to actually solve this, all we need to do is cross multiply and divide. Well, 5 times x is 5x. 2 times 10 is 20. To get both sides, or to get x by itself, I'm going to divide both sides by 5. And I get that x equals 4. So my answer to this problem, this base here, would be 4. And that would be true for both of them, because they're going to be the same. So if two solids are similar and the ratio between the lengths of their edges is 3 to 5, what is the ratio of their surface areas? Well, remember we said that surface area to surface area was equal to the side squared over the side squared. Or we could also say edge squared over edge squared. So in order to find the ratio of their surface areas, it's really easy. All I have to do is figure out what 3 squared is and figure out what 5 squared is. Well, 3 squared is 9. 5 squared is 25. So the ratio of their surface areas would be 9 to 25. The ratio of the volumes, so now we're moving on and talking about volumes. Volumes of two similar solids is equal to the cube of the ratio between their edges. So instead of being side squared over side squared, it's going to be our volume over our volume equals our edge cubed over our edge cubed. So if two cylinders are similar and the ratio between the lengths of their edges is 2 to 3, what is the ratio of their volumes? Well, if the ratio of the edges was 2 to 3, then the ratio of their volumes is going to be 2 cubed to 3 cubed. And 2 cubed is 8, 3 cubed is 27, so the ratio of their volumes would be 8 to 27. Moving on to the checkup. Tells us that number 1, the two prisms below are similar. What's the value of x? Since we're just looking for a side, it's going to be a normal proportion. Now we just have to figure out what we need to use. So we know we have to have x. I'm going to put that on top. And we've got to figure out something else that corresponds with x. Well, x and 4 go together because they're on the same side here. And x also goes with 27 because they're in the same shape. So I need to put 27 somewhere and 4 somewhere so that they go with x. So I'm going to put 4 on top and I'm going to put 27 on bottom. And that is okay for me to do that. So now I've got to figure out what's going to go in my other place. Well, in order for this to work, I have to put something that goes with 27 and something that goes with 4. Well, 27 and 9 go together. So the question is, does 9 go with 4? Well, 4 and 9 are in the same shape. So yes, they do go together. So that means I can put 9 on bottom. So I'm going to cross multiply and divide. I end up with 108 equals 9x. I'm going to divide both sides by 9, and I'm going to get x equals 12. So that would be my missing side length here, 12. Number 3, two cones below are similar. What is the value of x to the nearest 100th? So I'm going to flip over to the next page. So we're looking for x. X here is my height. So I just need to set up a proportion to solve this. So I'm going to put 9 over 5 because 9 and 5 go together because they're in the same pyramid over here. I'm going to put x over 8 because they're in the same cylinder, over here. And then I'm going to cross multiply and divide. Well, 9 times 8 is 72. 5 times x is 5x. Then I'm going to divide both sides by 5. When I divide 72 by 5, I'm going to get 14.4. So my missing height here would be 14.4. Number 5, the two cylinders are similar. What's the value of x to the nearest 100th? Exact same principle. Cross multiply and divide. So I have 12 over 3 equals x over 10. So I'm going to cross multiply. That gives me 120 equals 3x. I'm going to divide both sides by 3, and I get that x equals 40. So that means my missing height here would be 40. Number 7. If the two pyramids are similar and the ratio between the lengths of their edges is 3 to 4, what is the ratio of their volumes? So it says edges is 3 to 4. And we need to find the ratio of their volumes. Well, remember, for volumes, that means we cube each of those numbers. 3 cubed is 27. 4 cubed is 64. So the ratio of their volumes would be 27 to 64. Number 9, two prisms are similar, and the ratio between the lengths of their edges is 2 to 5. What is the ratio of their surface areas? So they are currently 2 to 5 for the edges or the sides. For surface areas, remember, we square them. And 2 squared is 4. 5 squared is 25. So the ratio of their surface areas would be 4 to 25.